I'm Adriana Thomas, a counselor at Echo Trail in Louisville, Kentucky. Welcome to our video highlighting the third recommendation from the Works Clearinghouse practice guide assisting students struggling with mathematics intervention in the elementary grades. The third recommendation is to use a well-chosen set of concrete and semi-concrete representations to enhance students' learning of mathematical concepts and procedures. Concrete and semi-concrete representations are powerful ways to make mathematics more visible and more accessible for students. According to the practice guide, concrete representations are three-dimensional, physical materials or actions that students can organize, act upon, or manipulate to better comprehend mathematical content. Examples include base 10 blocks, fraction tiles, counters like beans or bears, and role-playing. On the other hand, semi-concrete representations are two-dimensional visual depictions including strip diagrams, simple drawings, tables, arrays, graphs, and number lines. These visual aids can be used in conjunction with concrete representation to transition to more abstract representation. Abstract representations are mathematical notation such as numbers, equations, operations, relational symbols, and expressions. It includes elements like 4, 16, multiplication, and equal signs, and equations such as 4 times 4 equals 16. When implementing this recommendation, it's crucial to select representations that accurately model the concept or procedure being taught. For instance, if you are teaching patterns, concrete representations like pattern blocks or semi-concrete representations like pictures of shapes can be highly effective. The practice guide provides a valuable table with numerous examples of common concrete and semi-concrete representations suitable for various mathematical concepts and procedures. In this video, watch how the teacher used counting bears as a concrete representation to solve a single-digit word problem.
All right, we're going to kind of change it up a bit. Are you ready? All right, Caitlin, can you read this one for us?
4 bears are on the slide.
Keep going.
5 on the swings.
Very good.
Bears at the park.
Very good. So what's the first thing that we know, everybody? Noah.
4 bears on the slide.
Very good. Go ahead and put 4 bears on your slide right now. Brayden, what's the second thing that we know?
5 bears are on the 5 bears are on the swing.
Very good. So also put 5 bears on your swing. And Richie, what is the question asking us?
How many bears are at the park?
So how many are at the park? So what are we going to do? We're adding, right? We are adding the bears all together. So how many bears are at the park?
9.
9 bears are at the park. So you guys just subtracted and you added without putting any pencil in your hand, correct?
In the prior video, we saw how Miss McKinney began the lesson by practicing with accessible numbers 4 plus 5 equal 9 and used counting bears as a concrete representation. Next, she transitioned to more challenging word problems and chose to use counting sticks to represent the larger values in the word problem. Watch this video to see Amisha representing 32 plus 44 on her mat.
So think 32. We can actually even use our place values chart right here. How many tens makes 32? How many tens? Yes.
3 tens.
3 tens. So what does that look like on your mat?
So you have 3 tens and 2 ones.
Very good. So 32 is actually 3 tens and 2 ones. Does everybody have that? Yes. Yes. Very good. What's our next number, Noah? What does Amisha have?
44.
44. So now we need to set up 44. Go ahead and do that.
Next, watch how the teacher transitions from a concrete representation, counting sticks, to a semi-concrete representation, number lines.
How could we do it if I didn't have sticks with me? What's another strategy we could do? Yes?
Use your,
You could use bears. What else could you use?
number line.
Number line. So we have a big number line up here. Max, show me how you would use a number line to add 2 plus 4. Where do you begin?
You begin at the first number that you start with.
And which one do you want, 2 or 4? Does it matter?
No.
If we're adding, it doesn't matter, does it? So which one do you want to start with?
2.
All right, hands on the 2. What do I do now?
You count up to 4.
Do I go this way?
No.
No. Which way do I go?
The other way.
I go forward, right? Because when I'm adding, my answer is always going to be bigger.
Another key consideration when using representation is to present the mathematical notation simultaneously. This helps the student conceptualize the connection between representation and the mathematical concepts. In this video clip, notice how the teacher represents a student's thinking by drawing semi-concrete representations. A recommended next step would be to write the numbers 200 plus 100 equals 300 above the pictures. This will help the student see the connection between the semi-concrete representation and abstract numbers.
300, and then if you add 200 plus 50, that would be 250.
Oh, so Coralie, let me see if I can represent what you just said. You're saying if I add 200 plus 1 more 100, it's 300. If I add 200 plus 50 plus 50, what is it going to equal?
300.
It's going to equal 300, right? Excellent.
Remember that students will need many opportunities to use this representation, and then as they become more comfortable, they will be able to use them to model problems and build understanding. As students become more comfortable using representation, it is important to routinely ask them to use their representation to explain their solution approach. Finally, it is essential to periodically and repeatedly revisit concrete and semi-concrete representation to reinforce and deepen understanding of mathematical ideas. This practice is not limited to elementary students. High school students and beyond may utilize tools like algebra blocks, geometric models, and computer-based transformation tools. Our goal is to make concrete and semi-concrete representations readily available for all students, encouraging their use when necessary and revisiting them if students encounter challenges in problem solving. Stay tuned for our next video where we'll dive into the 4th recommendation from the What Works Clearinghouse Practice Guide, assisting students struggling with mathematics, intervention in the elementary grades. Thank you for joining us on this insightful journey.